In all of the probability theory that we've covered so far, something that I haven't explicitly defined for you but has been an important part of everything we've been doing is this idea of random variables. I'm going to go into formally defining them now. So a random variable is a variable whose value is determined by a process that has uncertainty. So all of the probabilities that we've been talking about so far, a coin toss, a picking a card, what the weather is going to be, all of these things are random variables because the value of that variable, is it heads? Is it the ace of spades? Whatever. That variable is determined by a process that has randomness, that has uncertainty in it. To annotate random variables, let's say if we have a scalar values, so if we had height, the height of a plant, that's a random process. It's never going to be exactly the same height, even if all of the plants in a species have generally the same average height. The specific height of any given plant is a random variable. There's uncertainty in that process. Well, we annotate that random variable in plain type, not in italics. We only use italics once a random variable has been assigned a particular value. So, for example, a particular state. So once the height of our plant is known, once it's no longer abstract, and we know that it's 172 centimeters tall, then we convert from that, that abstract scalar value for height being the plain type h to converting it into italics and saying, say, the first plant has a height of 172 centimeters. And this distinction between talking about the particular, say, height of something and the general random variable for height, this distinction comes in handy when we're working with probability equations. Okay, so the general notation and explanation of what random variables are out of the way, I can fill you in on the two main types of random variables. The first type that I'm going to talk about is the discrete type. So this is a random variable that has a countable number of states. And so we've talked about many examples of these kinds of discrete random variables already. So if we have a coin flip, was that heads or was that tails? If we have 5 coin flips, how many of them were heads? Those are all examples of a countable number of states of a discrete variable. And a key thing here is that discrete variables can even have an infinite number of states. So if we were, in theory, counting the number of cars in a country or something like that, it doesn't really have a finite limit. There's no kind of real cap to that. As I just mentioned, discrete variables could be a category, like heads or tails, or it could be an integer, like the result of rolling a die. So, a die can come up as a 3 or a 4 or a 1. The other variety of random variable is a continuous random variable. So these are real values represented by a float in computing. So they can have decimals. And so things like height, speed, temperature, these are all examples of continuous random variables because there's a gradation from 172 centimeters to 173 centimeters. If we had a more precise ruler, we could, more precisely define that value. So continuous variables can be distinguished from discrete ones in that way, where there's this constant, almost infinitely fine gradation between values. Nice, so that's our introduction, our formal introduction to random variables. Up next, we'll formally define how random variables make up a probability distribution.